Hi guys, Mr. Martin here with our last video in the Unit 3 series. This one is going to be on part 2 of proving theorems about perpendicular lines. So we'll pick up where we left off with part 1. Here we go. Alright, theorem 3.11 is the perpendicular transversal theorem. It says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the third. So you see in this picture we've got line H and K parallel to each other, and we've got line J perpendicular to line H. Okay, so what they're saying is that if it's perpendicular to one of the two parallel lines, then it's perpendicular to the other. So what they want us to prove is that J is perpendicular to K. Okay, so let's see how we can do that. Now remember what we know about parallel lines. We know that corresponding angles of parallel lines are congruent, right? So I think this proof is going to be a really easy one. And let's put some numbers in here to make it a little bit easier for us. Let's say that this is angle 1, and let's say this is angle 2. Okay? So if we can prove angle 2 is a right angle, then we can prove that J is perpendicular to K. So it's going to go pretty simply like this. We can say angle 1 is a right angle because J is perpendicular to H. Okay? We can say then that angle 1 is congruent to angle 2 because of the corresponding angles postulate. Okay. And therefore we can say, since 1 is a right angle, we can say angle 2 is a right angle. And then finally, from the definition of perpendicular lines, if angle 2 is a right angle, then J is perpendicular to K. Remember, these theorems usually are pretty easily proven, so take a minute and think about the proof for the theorem, and that'll make the memorizing the actual theorem a little bit easier. Okay? It kind of makes logical sense that if the transversal is perpendicular to one of the parallel lines, it's going to be perpendicular to the other. Alright? Alright, let's look at the next theorem in this video. Is going to be lines perpendicular to a transversal theorem. This one is going to look just like the one we just did. If we've got two lines that are perpendicular to the same line, then they have to be parallel, and we're going to use the converse of the corresponding angles. So let's put some numbers in here. Let's say this is 1 and this is 2. Okay, we can say if, well, that's a weird if. Let's say if M is perpendicular to P and N is perpendicular to P, then angle 1 and angle 2 are right angles. Okay? And say therefore angle 1 is congruent to angle 2 by the right angle congruence theorem. So if angle 1 and angle 2 are congruent, then M is parallel to N by the corresponding angles converse. Okay? Pretty easy. Okay? If the two lines are perpendicular to that transversal, or that transversal is perpendicular to both those lines, then it makes angle 1 and 2 a right angle. And then we know that all right angles are congruent to each other. Then we know that if the corresponding angles are congruent, then the lines are parallel. Pretty easy proof. I'm hoping for you guys these proofs are getting easier. Okay, keep writing down the theorems, keep writing down the proofs. You are expected to know all of the theorems, postulates, and properties. We keep building our catalog of knowledge, and as long as you write these things down, it'll help you memorize these theorems. All right? Let's look at an example of using this. Okay, they say determine which lines, if any, that's your big key that there may not be any, okay, must be parallel in the diagram. So let's look at this diagram, and you see a bunch of right angles in there. Let's put some numbers in there again. I think the numbers help us a little bit because we can easily name the angles. Okay, so I just numbered the right angles. Okay, so let's look at angles 1 and 2. Okay, see those are both right angles, and I think if we remember from our consecutive interior angles converse, if consecutive interior angles are supplementary, then those lines have to be parallel. So I'm talking about, that would be lines P and Q, and S would be the transversal. Okay, so we could say P is parallel to Q by the consecutive interior angles converse. Remember, the consecutive interior angles theorem said that if the lines are parallel, those angles are supplementary. So we can flip that around and say if they're supplementary, then the two lines must be parallel. Alright, let's go on to angles 2 and 3. Now we've got lines S and T being the lines that we're talking about. So now we're talking about line S and T, and now Q is going to be the transversal. So now we've got two angles on the same side of the transversal. They're consecutive, same side angles now. One's inside, one's outside though. So those will be called, if you remember correctly, corresponding angles. So we can say now that S is parallel to T by the corresponding angles postulate. Okay. So hopefully those aren't too bad. Those, once you know the theorems, it makes it a lot easier to prove things, and we were talking about all those right angles because we want to start recognizing that all angles are congruent to each other, or that two right angles are always going to be supplementary to each other. Remember, supplementary doesn't necessarily mean that they're adjacent, but they just have to have angles added to be 180 degrees. Let's move on. Okay, so there's the solution that we said already. Okay, and they gave some different ideas, different theorems. There's always many ways you can prove the theorems, prove the things that they're asking you for, and there's always going to be more than one right answer. All right, let's move on. Last two things I want to talk about. Okay, first one is how do we measure the distance from a point to a line? Okay, so if I said you're standing in the middle of the room and I wanted to know how far away you were from one of the walls, you could start walking to the wall in a lot of different directions. We could go this way, right? You could go a lot of different directions. And I want to know which of these would be the distance. How far are you from that wall? Okay. Well, what we do is we say that the distance is always measured perpendicular. So when we start walking towards the wall, we're going to walk straight to it. We're going to walk the shortest distance possible. And it turns out that the shortest distance possible is the segment that makes a right angle with that wall. Okay? That segment is actually the shortest path. So the blue segment here is what we call the shortest path. And I think if you think about that for a minute, walking straight towards the wall is going to get you there quicker than walking off at an angle. Kind of makes sense. So now that we say the measure of that distance is simply the length of that segment. So AB is the distance that you are from that wall. So we always measure distance perpendicular to the wall. Or we say the distance from a point to a line, the point being where you were standing and the line being the wall, is always measured perpendicular from the point to the line. Alright? Let's use that same idea to look at the distance between two parallel lines. How far are those two parallel lines apart? Okay? And again, we can measure the distance in lots of ways. But which way makes most sense? Right? We can measure the distance in a lot of different ways. Which of those segments is going to be the actual distance? Okay? I think you can see that there's a lot of different ways I can measure starting at any one point. Okay? Again, the distance between two parallel lines is the length of any perpendicular segment joining the two lines. So if you pick a point somewhere, it can be on either one of the lines. The shortest distance is going to be the length of that perpendicular segment. So in this picture, the distance between line P and line M is CD, which is the distance of the segment CD, and the distance EF, which is the length of segment EF. Again, kind of makes sense. You want the shortest distance possible, so those perpendicular segments are going to be the shortest distance. Alright guys, that is all I have for Unit 3. We have successfully conquered another unit. We're going to spend the next couple days reviewing, and we will be ready for the test probably on Friday. Alright you guys, let me know if you got any questions, and I'll see you in class.